I want to talk to you tonight about the most important thing in Eastern philosophy and aesthetics, which is space. Space, largely neglected by us as being nothing, even though our architects talk about uses of space, characters of space and qualities of space, and though our astronomers talk about curved space, expanding space, and therefore active space. There is a saying in the sutra, which is recited by all Buddhists practically in Japan and China, called the Makahanya Haramita Shingyo, or the Heart Sutra, Shingyo, which is a form precisely is emptiness. This character also means the sky, and so space. This means both form and color. It corresponds to the Sanskrit word rupa. It isn't the same as our word matter, which has come to have the meaning of stuff, substance in the sense of stuff out of which things are made. This refers rather more to shape, because there is not in Buddhist philosophy a concept of stuff. So what is shape? What is form? What is outline? What is significant, a perceptible or audible form is the same thing as space. Now, this is not quite what we mean by equal sign. When you get this kind of equation is in Eastern thought, that is to say, you will get a Japanese saying, Byodo soku shabetsu, shabetsu soku byodo. Soku means, these two things mean unity is differentiation, differentiation is unity. Now we know ordinarily that nothing could be more different than the different and the same. And people will argue themselves into a bloody fight that, by God, the same is different from the different, and the different is different from the same. And so when you argue it that way, difference seems to have an edge over sameness, doesn't it? Because you're going to argue the same is different from the different, and by God, the different is different from the same. There are more times the word different is used in this argument than the word same. And yet, you realize that you don't know what the different is unless you know what the same is. And that these two experiences designate each other. And it's this business of designating each other which is meant by these two characters here, which link form and space. And you could say they imply each other. That is a little better translation than are the same as. So then, we are looking at a culture here which in its aesthetics shows an immense valuation of space. Also, today, under the great pressures of the population explosion, space is the most expensive thing in Japan. More expensive than food, transportation, or anything else. Space. And it is a country which has learned how to make small spaces seem enormous. So great is the appreciation of space. So, in contrast with our point of view, for which space is nothing and for which space is also disturbing, look at the ways in which we find space disturbing. Space free from sound, called silence, is a form of space, and that is something which is to most modern people, whether American or Japanese, disturbing. Silence should be filled. And you know that in the Far East, where people have radios, they believe that they are not getting their money's worth out of the radio unless they have the current turned on as high as possible. They should get the maximum noise out of it because that's what, after all, it brings you. So turn it up high. This intrusion, therefore, into all life of constant noise to destroy silence. Silence bothers us. And so in the same way, space bothers us because there's nothing in it. And you remember those glorious Victorian rooms where no space whatsoever was allowed. The walls had to be covered with patterns. You couldn't have a blank page, say a blank area on the binding of a book, but you had to fill the whole thing up with flowers and curlicues and all kinds of things, and you couldn't have a surface of wood without, in some way or other, covering it all. All because of the feeling that space just is something that's not there. Now, what I want to do this evening is to show you various ways in which space is as important as the things that are supposed to be in it. And that once you can grasp that point, you have very many problems solved. Now let me start by repeating something that I've already told you. But I want to do this for the purpose of making it fresh in your mind and also illustrating it vividly so that you can't forget it. This is the most elementary lesson in space. And it starts with a universe in which there is only one ball. There has to be, of course, in this universe, space surrounding the ball. Because the ball is a solid, and the solid must go with the space. After all, if the ball is all that there is, then it's no ball at all, because nobody can see its limitations. And on the other hand, if the space surrounding it is all that there is, nobody will notice the space, because there won't be anything in it. So we have to start with a primordial world of ball or solid and space. These two poles or qualities, because the human nervous system is so arranged that the neurons constituting it have two possible operations: to fire or not to fire, to be or not to be. And so all thought is founded on an elaborate combination of what you might call yang and yin, or 0 and 1, on which, with these two symbols, you can put all arithmetic on that. And computers use nothing but these symbols, no and yes, to do the most elaborate calculations. So, our way of thinking is entirely based on is you is or is you ain't. And so we have a certain difficulty in realizing something in common between those two, which is suggested, you see, by this phrase, goes with. And about this come endless arguments. But at any rate, here is this universe in which all that there is one ball and space. In this world, of course, no motion is possible, because that ball cannot be said to be moving up or down or to the left or to the right, to the north, south, east or west, above or below, because there is nothing else in relation to which it can move. So we don't know even that it's still. We don't know whether it moves. Neither stillness nor motion can be attributed to it. It is only when we get a second ball, and now we're going to call them A and B, that there can be any motion at all. And so we can watch balls A and B growing closer to each other or further away from each other. But we cannot say whether A is moving and B is still, whether B is moving or A is still, or whether both are moving. There is no way of deciding it. They grow either closer together or further away from each other, back and forth, but we cannot decide which one of them is doing it. Furthermore, I want you to notice this, that these two balls can only move in a straight line. In other words, any position whatsoever in which they may be found will be along a straight line. And so they are confined to that dimension of motion. And so now we introduce a third ball, C. And we get a new problem. First of all, let us suppose that balls A and B stay together at the same relative distance from each other, and that C moves off. C. Now, the question arises, who has moved? Have A and B moved away from C, or has C moved away from A and B? How is this to be decided? You can decide it only on the rather fallacious basis of the majority being in the right. So that because A and B constitute a majority, they can decide whether they moved away from C or C moved away from them. And so by constituting themselves the majority, they can rule the situation unless C decides to stay with them at a constant distance. Then, so long as they stay together and C stays the same distance from them, they can't move, because they can only move in relation to C. The only thing they can do to demonstrate movement is to break it up. If C decides to stay here at this constant distance from them both, you see, the only way they can change the situation is to break up this and for B to move out here. And notice this, that in this situation, the three of them can only move within a plane, within a surface. Because wherever there are 3 points, they will always lie on a surface. Just as where there are only 2 points, they will always lie on a straight line. So here, in the first place, we had a one-dimensional world with 2 balls. We now have a 2-dimensional world with 3 balls.